All right, so this lesson is a great lesson. I did not develop it myself, but I love the approach that we're taking here. Usually, we show you how to graph trig functions and then show you how to find out the information about it. But this time, we're going to take the reverse approach. We're going to show you what a general periodic function is, which trig functions actually are periodic functions. We're going to show you what a general one looks like and then ask you to figure out certain properties about it. Now, it might seem really simple at first, but that's kind of the point. We want you to look at these, see that it's pretty simple to figure this out. That way, when you're looking at the trigonometric functions, you can focus on the trigonometry and then this finding this period, amplitude, cycles, all of this stuff would be actually really easy to do. So this lesson is particularly important. That way the next lesson is easy. All right, let's get into it. So as I alluded to before, we are talking about periodic functions. What is a periodic function? Well, we have this vocabulary list here, and these are the first three vocabulary terms that we're going to be discussing: periodic functions, cycle, and period. A periodic function is just a function that repeats a pattern of y values at regular intervals. Now that might sound very weird and mathy, but you will be able to tell what a periodic function is once we look at one. A cycle is a pattern that you see there, so every time it repeats a pattern, that's going to be a cycle, and a period is going to be the horizontal length that each of these patterns happen. So every time it does a cycle, what is the length of time it took to actually complete that cycle? I know it seems a little confusing right now, but let's look at a periodic function. This is an example of a periodic function. Now, how do I know this is a periodic function? Now, remember the vocabulary term that we gave you was it repeats a series of y values. What does that actually mean? Well, that means that whatever y value that we start from, let's say we start from here, this big green dot, and we're going to follow it down, and then we're going to follow it up. See how we made this like little V shape right here? That is going to repeat. And it's going to repeat, and it's going to repeat. So if I were to take this and move it to the right, it actually covers over here, and it covers over here, and it covers over here, and it would cover over here if the graph kept on going, and it would cover over here if the graph kept on going over there as well. But as you can see, that this is a graph that constantly repeats. Now, I'm not going to go too much into detail on a graph that repeats this way. Just know that that is what we're looking for in a periodic function. That's all well and good, but how do I answer this question? All I have to say to answer this question is that the y values repeat in a similar pattern. So question number 2, what is the period of this function? And we need to explain our answer here. Now, a period is just going to be the horizontal distance of a cycle. So the first thing I guess we really have to do is identify where the cycles are. And we've actually done that already. But we can start anywhere and realize that a cycle will happen. And the period, or the distance between that, will always be the same length. For instance, this green line that we already drew here, this goes from -2 to +2. So what is the distance that is traveled? And we can just count that. This is just going to be 1, 2, 3, 4. So far, we have found that this is 4, and we already know that this is a cycle because we've moved it across the graph. But what about this cycle right over here? It looks so much different than the cycle we had before because it is starting right over here, and then it's going up the cycle to the top point, and then it's going all the way down, and then it's getting back to the y-axis over here. How is that the same thing as the thing we had before? Well, wherever we start, we can finish the cycle as long as we're at a similar y coordinate. So this, in fact, would be a cycle, and if you look, the distance here is still 4. We start here and we go 1, 2, 3, 4. So no matter where our cycle is, if it is a true cycle, the period is going to be the same no matter what. So we're going to say that our period, we'll just label it P equals 4. Now, for the explain your answer portion of this, as you can see, you saw a couple weird lines on the right just pop up and some other stuff. So I have obviously just taken my time to write this and then cover it up with a poorly placed white block. And I feel way too lazy to figure out any better way of doing this. So, to the explain your answer portion of this question, from one point to an equivalent point, the horizontal distance is 4. That is the way of actually saying it. But we would just say the period equals 4. Now, how many cycles take place in the window from -5 to 15? So first of all, we want to identify where -5 is and where 15 is. Now for this part, I want to delete all of my markings and I'm going to make new markings. -5. First we have to identify where -5 is. This looks like -5 because -4 is directly to the right. So -5. Now we need to identify how far does that first cycle go. So as we can see that this first cycle goes all the way to the top and then down to the bottom. And that seems like that is an equivalent point that we can stop at. Now that is going to be the first cycle. And the question is just asking, if you keep on doing this all the way to 15, how many cycles do you get? So let's figure that out. The next cycle is right here. So we're just going to draw that really quick. We're going to keep this red color and this is going to be the next cycle right there. I am running out of colors, but that is okay. This will be the next cycle right after that. And last but not least, we have one more cycle here right at the end. So how many cycles did we do? We have the purple, green, red, yellowish, orange, and blue. So that's 1, 2, 3, 4, 5. 5 cycles took place between -5 and 15. So we could just say 5. The guided practice here is a whole lot easier than the questions that we just answered up above. All this wants you to do is identify the period for each of the function and then explain your answer. So this would be a great time for you to pause the video and just give this a shot yourself and see if you can do it. And I really do think that you can. Thank you very much for pausing the video, and I know you did because you are an awesome student. So here, what do we have? If you remember, a period is just the length that a cycle takes to complete one full cycle. So we can start anywhere that we want. Let's start, I don't know, at this top part right over here. If we start there, we're going to go all the way down and we're going to keep on going until we hit a similar location. And I think that is going to be our similar location. Now we could always test this out if this is a true cycle by just moving it over and seeing that it actually fits other parts of the graph as well. It actually works if we move it to the left as well, but it's just the graph got cut off and we don't see the rest of the graph over there. But this is a good indication that we have a true cycle. Now remember, the starting point can be anywhere. It just needs to get to a similar point. So how far is this? All we have to do is count. We have to say 1, 2, 3, 4. Same as the top one. 4 units is our period. So we would say P equals 4. Now the interesting thing, if we started from this point right here, which is a completely legitimate point to start from, how would that look if we're drawing our cycle? Well, we're going to go down and then up, and you might say, hey, we're at the same y value. But the problem with this is that you can kind of see that it doesn't really complete the whole thing. And if I move that over to the right, it doesn't really fit the top, and it's just not really fitting this graph. So we're going to have to continue and then wait until we get back down to here. And now at that point, you can see that it is really going to continue to do that exact shape as it goes on, and there's not going to be any other shapes involved. And again, it's just going to be 1, 2, 3, 4, and that is the period that we got with the other one. So as I said before, the period is always going to be the same no matter where you start your cycle from. Let's look at question number B. Now there's already a nice little blue dot right over here, so I'm just going to use that and try and find where my cycle is going to go. Well, I'm going to continue down, and it doesn't seem that completed, so I'm going to go back up, and that seems like that is my full cycle. If I move that to the right and the left, it would just fit onto the graph. So that is going to be my cycle, and now I just have to count the spaces in between, and I get 1, 2, 3. And so I'm going to say my period for this one is going to equal 3. Now, this does say explain your answer. All I would do is suggest that you look back up here for the answer for this one. From one point to an equivalent point, the horizontal distance is, and then you just put your period number. And because I am too lazy to write down that whole thing, I will leave it to you to do that yourselves. I have a cat. And Kitty, you must go. Alright, so here is time to play Is This Function Periodic? It is extremely late and I'm going crazy. A and B are both examples of a potential periodic function, and we need to figure out if they are. Now, A, you might say, well, Mr. K, of course that's a periodic function. If you look right here, I could draw a line, and then I can go ahead and move it to different parts of the graph. But I will challenge that this is not a periodic function. Why? Well, it's not repeating the y values. Visually, this looks pretty close to a periodic function. But see how it's going down? That means that this y value is different than this y value. Right at the spot that you would think that it would start to repeat, it's a completely different y value. And that kind of disqualifies it from being a periodic function. So, this is not going to be a periodic function. Now, the next one, you might think that it looks a little bit strange. It's a little bit wiggly. But I would argue that this is a periodic function, and we just need to find the right place to start. So, for instance, if you start here and go up and then down and then here, I think we need to go a little bit further. I think we need to go to about there. And that's going to be our cycle. Our period, it doesn't ask for period, but that's going to be 1, 2, 3, 4, 5. So it's a rather large period. But if we move this over, you can see that it perfectly fits onto the next part of the graph. And the y values do actually repeat itself. You can see that this top y value, if I move it over to this over here, it's the exact same y value as we had before. So even though that it looks a little bit weird, this would be a periodic function. So this one is going to be a no, and this one is going to be a yes. Now there's no guided practice on this, but we are getting to new vocabulary. So we're going to be talking about midline and amplitude. They are related to each other, and in all honesty, if you can find one, you could really find the other. I would say start with midline. Midline is probably the easiest to go for. A midline is the horizontal line that cuts the function in half, and the amplitude is the distance from that midline going up to the maximum or down to the minimum. So it's going to be the same on either side. And I know that still sounds confusing, but let's look at an example. Now here we have a graph, and a lot of things are already labeled for you, but just look at the graph itself. And we want to ask ourselves, what is the maximum? And that's just going to be the maximum y value. As you can see, it keeps on getting up to 3, but then it starts dropping back down again, then getting up to 3, and then dropping back down again. So this maximum is going to be 3. So we're just going to say 3. What is the minimum? Where does it get down to? Well, it goes all the way down to -1, but it doesn't get much lower than that. So we're going to say -1. Where is the midline? Now, I understand that this one has a big thing that says midline and an arrow pointing to it that's a different color than everything. But usually we don't get that. Usually we have to draw that dashed line ourselves. So how would we calculate that? Well, it's just going to be the middle point between the top and the bottom. So we could just kind of look. If the top part is 3 and the bottom part's -1, the middle point is just 2 from the top and 2 from the bottom. And that's going to be the middle line right there, or the midline. There is a way to calculate this, and it's just going to be, I guess you can kind of look at it like an average. It's not really an average because you'd have to take into all the points, but it's the average between the top and the bottom. So we're going to take the top, which is going to be 3, and we're going to add -1, and we're going to then divide that by 2. We're going to add the maximum plus the minimum and then divide it by 2. So what is 3 plus -1? That's just going to be equal to 2. And then we have the divided by 2 already, so that's just going to equal 1. So we would say that our midline equals 1. And as you can see, our midline, I should have wrote it in purple and I apologize, is 1. Now what is amplitude? Amplitude, once you have your midline, is actually super easy to be able to find out. All you have to say is how far above the midline it goes and how far below the midline it goes. As you can see right here with this set of arrows, that it goes 2 units above the midline. And it also goes 2 units below the midline. So our amplitude is just going to be 2. You're not going to add them up or anything like that or anything weird. You're just going to say, well, it's 2. It goes 2 above and it goes 2 below. So the amplitude, A, equals 2. Now let's give this a shot. Here we have a guided practice, and we want to find the amplitude and midline of these periodic functions. So I'm going to give you a moment to yourselves to figure this out. Press that pause button and then press play once you're done. Fantastic job. Now let's see if you guys were right. My favorite thing to do first is to just find the midline. And we're going to take the maximum value plus the minimum value and divide that by 2. So the maximum value is going to be 1. Oh, I almost made a mistake. It's not 1. This, as you can see, goes up to 4 in 2 units. So this has to be 2. So I'm going to write 2 plus my minimum. Well, what is my minimum? It looks like that's going to be -4, so I'll say -4, and we're going to divide that by 2 because we're averaging out the top and the bottom. So let's see what this equals. 2 plus -4 is -2, of course, and then dividing that by 2, that's going to equal -1. So in this case, my midline is going to equal -1, but we also have to find our amplitude. Now, a nice way to find our amplitude is just to actually draw out our midline. As you can see, I did a horrible job of drawing out the midline, but that is completely fine because we have 1, 2, 3 units above. Remember, each full unit is 2. So if we have a midline at 1, this half unit, that'll be 1, 2, 3. So my amplitude is going to equal 3. So my midline equals -1 and my amplitude equals 3. It goes 3 above and 3 below. Now, I do want to say one thing. What if you're not good or you get a little confused with how the units are working, especially if the grid is off or something along those means? How would we be able to find our amplitude if it gets a little bit weird? Now, there is a really easy way to do this, and that is going to be, we're going to take our maximum, and we're going to subtract our midline. So what is that going to look like? Well, our maximum is going to be 2. And our midline is going to be at -1. So we're subtracting -1. What does that equal? Well, 2 minus -1 is the same thing as adding 1. So that means that this is going to equal 3. So again, once you have your midline, you could find your amplitude rather quickly, even if you can't count it because of a stupid grid or something like that. So let's look at question number B. Now here we have to first find our midline. So we're going to take our maximum, which in this case is 1, and this time I am correct. We're going to add it to our minimum, which is going to be -2, and then we're going to divide it by 2 because it's an average. So what does this turn out to be? Well, the top is going to be -1. That's 1 plus -2, or -1. And it's going to be over 2. Now, another way of looking at this would be saying -0.5 if you want it in a decimal format. Either way, it's at a middle point of a grid, which is okay. Remember, we have that fancy formula there if we can't count it accurately. First of all, we're going to say our midline equals -0.5, and now we're going to draw it out. Again, I am not artistically gifted into drawing lines, but that's all right, we get the idea. Now we could count, and you would be able to accurately count that this is going to be 1/2 and then 1, or 1.5 is going to be our amplitude. But let's say that we didn't know how to do that. We're going to do our max minus our midline thing and see if that gets us to the right answer. Again, remember, 1.5 is the correct answer. So we're going to do our maximum, which is 1, and we're going to subtract -0.5. Now, if we subtract a negative, again, that's adding, so that'll be 1 plus 0.5, and indeed, our amplitude is going to equal 1.5.